Hello, I'm Sam, an A-level maths tutor at ClassRx, an online one-to-one STEM-focused professional private tutoring company. I have a degree in physics from the University of Oxford, and I tutor maths and physics at both A-level and GCSE. I want to help as many people as I can get the grades they deserve, because I love maths and physics, and I want to show that everyone can have fun and do well given the right teaching. In the next 3 minutes, I will teach you the integrating factor of solving first-order differential equations, which is part of the A-level maths curriculum. These are very important as they get continued to use all the way through university for maths and physics both. So, integrating factors. We start off with an equation of the form dy by dx plus p of x times y plus q of x. This is the most general form of a first order, so that means only dy by dx, there's no d2y by dx squared or anything higher. Linear, which means that there's only multiples of y and dy by dx, there's no y squared or any functions of y. Any first order linear differential equation can be rearranged into this form. So what I'm going to do now is we're going to look at this special thing that I've written out. So if you look at this term here, if you notice when you differentiate it, you get something that kind of looks a bit like these first two terms, times by something else. So if you differentiate this y e to the fx, you get a dy by dx times e to the fx, that's this term times by e to the fx, plus dfx by dx times y times e to the fx, which is kind of like px if p were dfx by dx times y times e to the fx. So we've got both of them times by e to the fx, but also it looks a bit like this. So how do we use this? So if we say that fx is the integral of px dx, then what that means is that df by dx is p. So this becomes p. So what you end up having is d by dx of y e to the fx is equal to dy by dx times e to the fx plus p of x times y times e to the fx. So what you end up with is this term, this whole side of the equation, multiplied by e to the fx. So we call this the integrating factor. If you use fx equals the integral of px dx, and you times the multiple, you can use this to solve these equations. So I've just put this back at the top and through some space. If we write out this equation timesing both sides by the integrating factor, you have dy by dx times the integrating factor plus p of x times the integrating factor times y plus the integrating factor times q. And then, as you remember from the previous slide, we could rearrange this so that this is just the differential of the integrating factor times y. So if I find the slide here, so yeah, so here and here, that's what we did. And that equals to e to the integrating factor px times dx times qx. So what you can do, now that you have these in a bracket, you can integrate both sides with respect to x, and then you have a y, which you can just divide by the integrating factor again to get the solution for y. Now this all still looks a bit confusing, I know, because there's things flying everywhere. So let's have a look at an example, because that's what's going to clear it up. It did for me anyway. So here's the first example we're going to look at. We're going to look at dy by dx plus y is equal to e to the minus x. Now if we write a general form of the equation, we can see that px in this case is 1, and qx is e to the minus x. So if we use px is 1, and then we write out our integrating factor, which is integral of px dx, then that is equal to x. We don't need to worry about any constants at the moment because we're always differentiating it. So the integrating factor is e to the x. So if we write that at the top, if we times both sides by the integrating factor, we get e to the x dy by dx plus e to the x times y. And then if you remember how we wrote that out beforehand, we can write that out as d by dx of the integrating factor times by y, because this term differentiates to give this, and then you add it on because of the product rule to get this one. And then e to the x times e to the minus x is equal to 1. So on the other side of the equation, you just have a 1. So now what we do is we integrate both sides with respect to x, which means that it gets rid of this d by dx. So we've got e to the x equals x plus c, because we integrate 1 to get x, and then you've got to remember you're integrating constant. So then the only thing we need to do now to get y on its own is divide by e to the x. So that leaves us with y is equal to e to the minus x times by x plus c. Now this is a super useful way of solving first order linear differential equations, and you'll use it all the way through uni and A levels and everything. So it's totally worth getting down on top of. Thanks for watching. I hope you learned something. If you have any questions or would like to contact us, please visit classrx.com or drop us a line at hello@classrx.com. That's hello@classrx.com, mentioning my first name, Sam, in the subject line.